everyone. So Sonny was supposed to present this talk. He couldn't be here today, so I'm going to be presenting on his behalf. My name's Nicolas Lara, and I work at Osmosis, which is the leading DEX and liquidity venue of the Cosmos ecosystem. And since this is an Ethereum conference, I'm going to first do a quick introduction of the Cosmos ecosystem, in case some of you are not familiar with it. The Cosmos ecosystem is a network of independent blockchains that are generally, but not always, built with the Cosmos SDK. And the main thing is that they interact with each other using this protocol called the Inter-Blockchain Communication Protocol. Now, this is how the network looks right now. It's a bunch of chains. They're following pretty much every crypto use case that you want to build. There's a chain for it. And the central idea that we've been building around is that each of these chains can make all their engineering decisions based specifically on this use case that they're trying to build around. So you have chains that are a DEX, a privacy chain, liquidity chains. You could have DA layers. And all of those could customize sometimes small things like block times or block sizes, but it could be bigger things. It could be different execution VMs, could be different mempools, consensus algorithms, or it could be using the MPC capabilities of the validator set. So OK, so we've been building in this heterogeneous environment for a long time, which means we have to think about all these different types of chains and like all these differences that appear in them, or have these protocols that are higher level. So if you're building applications that interact with all of them, then you cannot really rely on all of them being the same. And this is what this talk's about, like the problems that have arisen when dealing with this in Cosmos, the solutions that we built to address them, and the open issues that we're still trying to solve. So there we go. Why does this matter for the Ethereum ecosystem? So the idea of L2s is not really new. It's been around since forever. But the amount of L2s and like the difference between them and how much they're interoperating with each other and like the different ways in which they communicate has been growing a lot lately. And I don't think anybody really believes in this idea that one chain will actually win outright and that you will have everything happening in one place. We're instead building these apps at a higher level that have to interact with multiple chains to be able to do what you want to provide to users. So the first thing you need to build when doing something like this is a message passing protocol. And that's what IBC is. I'm not going to go into all the details of how IBC works internally. But basically, IBC uses light client verification of the counterparty chain state and off-chain relayers that update the light clients and notify chains of posted messages. There are other designs of general message passing. There's like notably Layer 0, Axelar's GMP, and Hyperlane. And they all serve as this base layer, but I think IBC is one of the most secure and general architectures for this. And a new version of this is actually being developed. It's codenamed Eureka right now. And that's actually going to make it easier to bring IBC to EVMs because it simplifies the protocol a lot. Now, one of the first things that you implement once you have a a general message passing protocol is token transfer, right? The general way you implement token transfers, you lock it in one place, you pass the message to the other chain, you let them know that that has happened, the other chain can mint the token. Now, one thing that I've seen, even for like the more advanced intent-based token transfers that are still being proposed, is nobody thinks about implementing multiple token transfers. That's like a lesson that we've painfully learned. They spent countless hours and people like trying to work around the fact that you can only transfer one token at a time. That was done wrong in the initial implementation for this in IBC. It's been rectified on the newer one. But once you start transferring value, then one thing you have to think about is like, what do your accounts look like, right? In this heterogeneous environment, your accounts don't necessarily look the same everywhere. You cannot assume that just this type of address is going to represent you everywhere. And so one thing we do in Cosmos, simple, we encode this as spec32, we add the chain name at the beginning, and there are trade-offs that makes it harder to recognize the address directly. You look at it, you're not really sure if that's your address or not, because there are these checks on bytes at the end. And There's actually a really good solution for this on EVM, that is this ERC. Just stick the name of the chain in front of it. But the problem with this is that you actually don't really know who owns this account, who actually controls it. Because this might be true, but even for EOAs, you could have a chain that has implemented account derivation differently. So even if you control that account on one chain, you're not sure that you can control it on the other. And that gets even more complex when you consider something like smart contract accounts, or even just something as simple as a multi-sig. You would end up with something like the Wintermute hack, where somebody sent tokens to an account that they are supposedly controlled, but was not initialized on the receiving chain. So a hacker was able to snipe it. So what we can do instead to avoid these issues is to lean heavily on registries. We've tried a couple of registry designs in Cosmos. None of them has actually stuck. So I'm guessing this means that the design of this protocol is not as good as it could be. But you actually do have a de facto standard in ENS domains. And I think this is the best bet that we have to have a general registry system that you can use across all chains. But of course, I think it should evolve a little bit. You need to have, there are three important parts that you need to have. That is like the top level owner of an account. You need to have sub-accounts, and you need to know which chain you're interacting with. So having something like that, it generally would help you identify the account, but it will lead to one very obvious problem. That is like you're linking all of your accounts. And yes, you could use statistical methods to determine which accounts are linked to each other, but that becomes a lot easier when you're just giving that information away. So I think instead you could use this concept of asymmetric names. Asymmetric names is when you have these names that are interactively verified. So you could generate accounts on the fly that are used only as a receiver. And you have a way, those are all derived from your private keys, and they're all controlled by you. So it becomes kind of like a UTXO model. But something that's even better is that you can then take those tokens that you have received there, and they could be just streamed through a privacy layer to the account where they're actually supposed to live at rest. And in something like Cosmos, this would go through a set of different chains before it lands where you need to have it. Now, once you introduce abstract accounts or smart contract accounts, you end up in the situation where you have created a set of complex permissions that you have on one chain, and you want those permissions, like this is how you interact with your accounts. You don't want to have that in every chain. So once you have set this up, you don't really want to have to transfer that to every chain. And once you want to change your permissions, then you would have to actually adapt it on every chain that you've interacted with. Instead, one solution from Cosmos is this idea of interchain accounts. Interchain accounts use this controller host architecture that allows you to create an account from one chain to the other. So like your account on one chain can have an account on the second chain, and you can control that only by sending messages from the controller on the controller chain. Now, there we go. There's one big problem with this, and it's latency, right? If you have one account that is your main account that is controlling everything else, once you want to do an interaction with any other chain, you would actually have to initiate it on your controller account. And even if that is a very fast chain, you would end up having a latency of, like, at best, 1 second. And that's probably not good enough for what we want to build. So even when you do that, even if you're OK with your 1 second and controlling everything from one account, you have two other problems. One is that you need to initialize your accounts in every chain. You cannot just start using a chain that you haven't used before without creating an account there. And the even more important problem is composability. You normally want to interact with three different chains. And in all of those chains, you want to execute different actions. If you wanted to do that by controlling your chains from one central account chain, then you would end up having to sign all these messages. And you have to do this off-chain coordination of which order things are going to happen, what happens with failures. And instead, what we want to do is we want to have this general model of cross-chain execution. You want to start your interactions in any chain, and as you do that, the interaction should automatically move through all the steps that are needed to complete. So if you want to send tokens to a chain, swap them there, then send those 2 tokens to another chain, an LP there, you should just be able to sign one message and express that you want to execute that, and all the other executions should just happen automatically. And that is something that we've built for Cosmos, and we built it in this way of having nested messages where you specify what is going to be happening on each step. Each one of these messages is either a token transfer or a contract execution, and it's followed by another of these operations. And if you zoom out to what this is actually just monads, right? Like this is just one big operation that gets processed, and as the operation is processed, it returns you 2 of the same operations, one for success and one for failure. If you succeeded, you execute success. If you failed, you execute failure. And as you have that, that is just a general model of computation that you can use to do basically any sort of execution across all chains. Now, there are challenges for this, right? Once you're dealing with these 2 chains, who's doing the execution? You initiated the action in one chain. What account is doing the execution on the second one? And the way we've solved this is we've created, as you transfer tokens, one account gets created for you automatically on the receiving chain that is only existing there for this particular execution. Now, that account has received the tokens and can act on them. As that account sends the token somewhere else or executes new actions, new accounts get created for that. So those can only be controlled for this particular execution. Now, this has a nice side effect that you actually have to send your tokens along with your transfers. So you don't have to rely on like having tokens be there in those accounts beforehand. Now, who's paying for it? In Cosmos, unfortunately, right now, this is altruistic relayers. In ETHland, you actually could just use a paymaster for this, which is really good. And we're working on like a fee system for getting around this in Cosmos right now. Now, you're posting the execution data on-chain. Like, as you start your execution, you're saying, this is what I want to do, and you're getting that on-chain. That can be pretty costly in some chains. So what you want to do is you want to try to avoid that. And if you think this is costly, you could just, instead of posting the whole execution, you could just post a commitment to it, just post a hash. And when you relay your messages, you can include the execution information. Now, you have to deal with dynamic information. That is really difficult. I think the best solution we have for this is having some sort of query language that you can actually use to act on the previous execution's results. But this is not something we've implemented. It's like too complex, and like the advantages are not good enough. I mentioned before cross-chain latency, and the cross-chain latency here is not the same that I was talking about before. Before, you had this issue of when you start your execution, you have to wait for the execution to start until the second chain receives it. Whether here, the latency is just the amount of time this execution needs to take anyway. If your actions requires 3 token transfers and 3 actions on each chain, that's the minimum amount of time that this should take. And of course, if you are saying what you want to execute on the first step, and then things are going to happen, say, a minute later on a different chain, you'll have this MEV issue, right? But first, I think this is not something that you need to solve at this execution layer. You need to solve it at more of a privacy layer. And the simplest way to get around this is just what I said before for execution data being on chain. You don't post all of it. You just post your commitment, your hash, and then as you execute, you actually reveal what needs to happen. There are some standards that I think would be really useful in ETHland to implement all of these, but like the hard part, even after we have this, is what is the top-level protocol that we're going to implement that is going to allow us to communicate both with EVM chains, but also with Cosmos and also with Solana. There's like a way of specifying your cross-chain interactions that you can use across all these chains. Now, even when you've taken care of all that and you can do this execution across chains, one big issue that we have in terms of UX is this idea of asset fragmentation. What users actually care about is which underlying assets you're interacting with, what risk you're incurring on, and being able to just use those assets on applications, right? So if you have an application that works across multiple chains, you end up having many different variants of one asset that are spread out in different chains, and they may or may not have the same name. And they also may not have the same liquidity. They may not be able to be used in every application. So centralized exchanges do the opposite, right? They show you just one version of the asset, and they just don't expose the risk at all. You just don't know what's underlying there. You assume it's variants of the same asset, and hopefully it is, but you don't really know it. And at Osmosis, we've developed this concept of alloyed assets. Alloyed assets is just basically a pool of all these variants that can be swapped one-to-one. So then the LP token of this pool actually becomes the canonical version of the asset. In this case, you would have like a Bitcoin that is the representation of Bitcoin on Osmosis. It's just the union of all these variants of Bitcoin that have been bridged. Now, this is, of course, socializing the risk. But users can also choose to use the variants directly if that's what they want. And certain applications that don't want to use this alloyed asset can also choose to just use one variant. Now, one cool thing is that the original issuer of this token, if you have on-chain governance or even with off-chain governance, you could be the one that decides which variants are allowed in this alloy, right? Like you could have, for example, the Ethereum Foundation start these pools in different places and say, these are the tokens that are allowed here. Other people will provide liquidity, but these are the tokens that are allowed as canonical ETH. And the same way it could be like for chains that have on-chain governance can decide which assets will be part of this. Now, a cool thing with this thing is that it doesn't really need to be something that only exists on one chain. You would be tempted to just take this asset and like send it everywhere, but then you're basically just creating one more variant of the asset, right? So what you can do instead is just have these pools exist on every chain. And that is what is considered across all chains the canonical version of one asset. So everywhere when you're referencing Bitcoin, you would be referencing this thing that is a version of Bitcoin that has been bridged through these 10 bridges that we, through social consensus, consider to be valid bridges for Bitcoin. And those could also be just rebalanced across themselves. And I think a lot of this that I've been going through is basically that we need better cross-chain standards, something that doesn't work just within one ecosystem and that works with chains that are very different to one another. And yeah, this probably leads to standard proliferation. But I feel like some standards do win out. It's not necessarily true that the more standards you add, the more standards you have. Eventually, people will move towards the better ones. And I think in general, we want to move more towards this user-centric view of blockchains. Users want to have accounts that are easy to identify. They want to see all their assets across all chains. They want to have better execution across all chains that they can easily specify. They want to have protocols for asset identity, so you know which assets you're interacting with, but without having to you yourself go into all the details about the risks. And they want to be able to share their account permissions between chains. We're trying to apply all these lessons to our new product that is called Polaris. And Polaris is a token portal to trade all assets on all chains through one app. And we're hoping to be able to build better cross-chain standards along the way. We're going to be interacting with pretty much every chain out there. So when there are no good standards out there, we want to help build it. So yeah, if you have good or bad experiences either building or using cross-chain applications, just please come talk to me, because I'd love to hear what you think and try to work together in like making better standards and unifying them and improving them. Thank you for your time.
OK, thank you, Nicolas. Let's see the questions.
Yeah.
So we have 3 questions for now. First one is, how do you see the lack of middleware functionality in many bridges compared to IBC's ability to execute commands through middleware and IBC memo impacting mass adoption and UX in cross-chain ecos?
Yeah. We need better bridges. we need callbacks on bridges. IBC is, obviously I believe in IBC everywhere, but yeah, if we don't have IBC everywhere, if we use other bridges, let's use the ones that have callbacks. And I think as we start implementing functionality that use these type of like middlewares and callbacks, then that's the ones that people are going to use because they just provide a better better possibilities for building applications.
Okay. Next question is there a Cosmos version of the ERC 7683 standard?
Since I'm not an ETH person, if somebody can tell me the name of 7683, then I can probably answer that.
Is there anybody who, I don't know. So,
yeah.
Who has the question?
Is it the cross-chain intent? Or is
they're
it
shy. Okay. You can answer this later in discussion.
Yeah.
Okay. Next question is, what is the biggest benefit of having a standardized interoperability standard across the ecosystem versus various bridges in Ethereum?
Mm-hmm. So I think there are two different things. Like the interoperability standard would be for being able to, like, regardless of whether you have one bridge or multiple bridges, you could have one interoperability standard built on top of that. So, and I think the advantage is applications can build using basically this language, and then if a new bridge that is better comes along, your application will still work there. Now, versus having various bridges, I think it's good to have various bridges. They have different properties, and yeah, if some are better, they'll hopefully win.
Okay. Next question is, why not use the EEA cross-chain interop spec that was recently released?
Is it 7702? No? I'll probably have to look at it. Like, I think we worked on the, if it's recently released, I guess the answer is we built this before. So, oh, wonderful. Yeah, I'd love to look into that.
Okay. Next question is, you mentioned the privacy layer before a transfer from upchain to another one. Isn't it possible to ends up, sorry?
Yeah.
We lost the question. Is it to ends up being targeted by the governments like Tonaj Cash?
Sure, yeah. I mean, I feel like everything can get targeted, even just like blockchains in general. But that's why, I like the idea of having this as an optional layer that you can have. Like in the case of these ephemeral accounts, I was thinking like, so your name registry actually provide this different set of accounts that you can interact with, right? Like things get pushed to them. And then you have, again, basically an UTXO model, right? Like you have all these things that you control and you can move through there. And that gives you some sort of privacy. Now, if you actually want this to be streamed through a privacy layer, then what would happen is you would have something that is slowly moving this thing to another chain that does privacy and then moving out of it. Yeah, if that chain gets shut down, then you probably would have to do privacy somewhere else. And yeah, I think other privacy solutions would come out.
Okay. Next question is, how will Polaris handle the reorgs of layer 2s?
How Polaris will handle reorgs of L2s? I don't know. That's a good question. So Polaris is working at a higher abstraction level. So I believe like whatever our provider APIs are doing there is what we'll do, like for EVM chains. But yeah, again, good question. Give me your opinion out there.
Okay, we have 20 seconds, but it's not enough to answer the next question. So you can take it there, and thank you a lot. Yeah.